Yeah, so what I did for the last 3 days was implementing dance element attribute for modal types. And this is not in the list, but you can think of dance elements attribute and dance string elements attributes are the child class of this. So if you look at the class diagram, it looks like this. So dance element attribute is the top parent class of the dance FP elements attribute and dance string elements attribute. And these are so these two child classes. And if you have ones, then you can create a constant of dance tensor. So, and maybe sometimes this dance tensor can only have one element, that you can use this syntax without square bracket, that we say it is splatted. So if you query if it is splat, then this case true and this case false. So this is the way to create a constant from a tensor attribute, dance attribute. And the background is as follows. So yeah, we had a so we can create a constant from a dance attribute. The problem is the built-in dance elements doesn't know about modular arithmetic types. That's why when we create a dance constant, we use something like this syntax: colon type and colon type. And this is very awkward syntax because we usually input a type, we only add a single colon, but in this case, this dance elements attribute doesn't know about our custom type, so we need to add a type for one of these. In this case, int, and then we can add our type in the last. And both arith constant operation expect two attributes: integer attribute or dance int elements attribute. That was the previous situation. And this approach has the following drawbacks. One is the method might be usable up to the prime field that this is prime field PF. Okay, PF. But it's very difficult to extend to more complex types like F2, a fine point, or etc. Also, the method for creating dance elements attribute is complicated. Like for example, if you want to support let's say some way we use this syntax to support this complex type. The problem is so we need to add whenever we find code using a dance elements attribute, we needed to add a patch like that. So every time we introduce a new type, we need to add another if-else branch for every types. That's the second drawback. The third is MRI code is unaware of these custom types. If-else, and then and to create a the second item is something like this. So in order to create a dance elements attribute, because it only accepts integer, that's why we need to adjust some error code to create these elements from an integer. That's what I said in the second item. And third item is whenever we introduce every type, we need to search every case and we need to add another if-else branch. This is the three drawbacks that I found that for the existing approach. So, and another background that I need is something like this. So this is a example code that I try with George. And here we have a constant of 1. And the above Python code should generate these following MRI code. But, because our existing dance attribute doesn't know how to deal with this, how to deal with creating dense elements using this type, which means, yeah, in a Python code, I can actually do the same thing in a Python that it works, but it's not an ideal solution. That's why I start this code. I mean, this here, kind of. So now, yeah, I mean, in conclusion, this will be the one simple line, and this could be also one simple line and support all the types. That's what I try to persuade in this presentation. So first, I attempt, and before the ideal solution, I also try in a first trial with this approach. So yeah, let's try add our custom type inside this dense elements attribute, because here it tried to support these three different types. What about adding another attributes that depend, inheriting this, or add another if else branch to create our custom attribute? That's my first attempt here. And the problem is like, yeah, it worked, but the problem is like, so I don't know the entire LVM code that uses something like this if else branch. So in order to use this approach, I need to find every place that uses this if else branch, and I need to add this. Another if else branch. Otherwise, sometimes it will cause a program crash, because existing built-in dense elements attribute assumes that the element type is either one of integer, floating point, complex, or string. If you break this assumption, then it might end up with a program crash. That's very dangerous and that's very critical. So I dropped this attempt. Do you understand?
Yeah.
So the second attempt that I tried to do was like adding a almost similar structure like that ZkIR, dense elements attribute, and this analogous to the existing dense elements attribute, it has this child class. I don't have this one yet, but I tried to make this kind of structure. And then I want to, unlike the existing way to create a constant, I also try to support a similar syntax, but with only one type definition. Now it doesn't have to mention an additional column. It's enough to have a one additional column, because this dense element attribute has a custom logic of parsing. Also, it also supports splat syntax too. And with that, then now modal is constant operation now expects two attributes. One is integer attribute, the other is dense mode arith elements attribute.
So currently this syntax is enabled?
Yes.
Nice.
Yes. So but the problem is like, so this one should be inside MRI assembly parser, because this is where to try to parse attributes. Then if I add a dependency of this to here, then I have a circular dependency like that. That's why I needed to split header part that contains nothing about our custom type, and the source code that depends on every custom types. I need to split two classes or two build targets. So I didn't describe here yet, but in a README, if I just go back, just wait a second. So if you go to ZkIR README, yeah, I had to have I didn't mention also dependency, the build target, but I had to have a target that only has a header that has no dependency at all of our custom dependency. And MLIR side only depends on header. And that's why you will see another patch to MLIR or in ZkIR. I need to add this dependency later. I need to delay adding a dependency later to at the end of the CC binary dependency. So when creating a CC binary, when link at the linking time, it needs to know all the symbols so that I need to add this dependency to the CC binary. That's the strategy to enable this structure. Otherwise, I end up with a circular dependency. And another problem or issue that I met with these dense attributes is constant folding, because this constant folding uses dense elements attribute if the folding is happen on the tensor level. So I try to make an additional presentation on top of the base presentation earlier in this year. So I try not to repeat the same content already handled in this presentation. So I just try to just remind you how this constant folding works, and then what might change because of that. So for example, if I remind you of what is constant folding, it's like constant folding. It's like if you have a operation that has a constant, then it compiler side, when you generate the code at the canonicalization phase, you try to one of either reduce the number of operation or it computes the constant values. For example, if your operation is like arista add I, and left hand side and right hand side both are constant, it will fold it into the C3, which is the sum of C1 and C2. This is one way. The other is like at the canonicalization, you need to reduce the number of operation. That's another purpose of the canonicalization. So the process of constant folding is as follows. First, operation is folded, and then if the operation is folded, then the dialect side, it is called with this callback, dialect materialize constant. And if it doesn't return null pointer, or it doesn't return null pointer, then the operation is really materialized. So this three steps is the sequence of folding. So, and I'm not going to describe in a backward order. So for example, this line now this line and this line is added. I don't remember, this line could be modified, could be supposed to be like dense into elements attribute, something like that. Anyway, this was added, and I tried to tell you why it is added. So for example, the reason for adding this line is because from a tensor folding. So let's say if we, oh yes.
Which dialect constant up is it?
This is moderate because, yeah, moderate.
Okay, so, okay.
Yeah. So let's say if we have this MLIR, so because the operation has a constant value, so every operation should try to fold. The result after moderate bit cast is folded like that. So because this %0 is constant, so it will become moderate the constant with a dense tensor like that. Yes.
Question. I think the correct result should be arith constant, because that is not a valid.
Oh, no. It's not a moderate arith. It's a canonicalization only. So it doesn't lower.
Yeah, it doesn't lower, but folding can lower. I mean, folding can change the operation, right? So
yes, yes, yes,
every
yes,
constant.
yes. But this is intentional. So yeah, maybe previously it was like arith, but now before lowering, I try to keep it at the level of mode arith.
But do you think this syntax makes sense? I mean, moderate constant dense of tensor integer?
Then I think it's my fault to copy paste maybe. Yeah. Then yeah, sorry. Then it's my fault.
But I think
It's my bad.
Okay.
Sorry. Yeah, it's my bad. Yeah. So now at the time of folding of tensor the extract operation is now because it's foldable and it's trying to fold. And if you remember the order of sequence, now it's time to call tensor dialect naturalized constant callback. So if you look at the tensor dialect naturalized constant, so I switched also there's so before that, this was in here. And this makes unexpected result because, that's why I said that previously maybe, because we have a different bitcast, like for example, we could, RFEM.
Mermaid.
Yeah, mermaid, is the way to create a diagram model arrays. Let's say if we have this model arrays and we create first I32, and then we can make a tensor from integer to model arrays. This is a valid MRI code.
Yeah, the first constant should be arith constant.
No, yeah, that's why I said, I tried to make it model array constant when characterization. So this one, fold it like this, constant.
Yeah,
This
the
is
output should be moderate constant. I agree.
Yeah.
But the percentage zero should be arith constant.
Yeah, that's because the previous assumption I changed, because I changed the previous assumption to this assumption. So model is constant. Before that, it assesses dancing into elements attribute, right?
I mean, the moderate constant's output type should never be integer, no? The moderate percentage zero.
This is my another bad.
Then bitcast.
No. Yeah. This is another. Yeah. So that's another bad. That's another my bad. So in this case. Sorry.
I just confused me.
So after this, I want to create a. No. Maybe I think tensor from elements, maybe.
I think that's extract.
No. I mean, this. I think this one. Yeah. So tensor that extract when at the time of folding, tensor that extract. Now it also come into this code, right?
Mm-hmm.
If the arith is at the top, then this will result in, I believe, maybe arith that constant of something with an attribute. Because
okay.
Because if I remember correctly, arith the constant OP metrized allows a very wide range of attributes. So it tried to create a arith constant OP.
If I remember correctly, it checks with the type. Is buildable with?
Yes. The last element is attribute. So integer FP and attribute at the last type is the attribute with a constant OP. That's not what I wanted. So that's true. It's buildable with returns true if I move it to the top. That's why I needed to move this to the top so that if I have a constant type, even if it's an attribute, I want to create my own constant with that custom attribute. So yeah, so that's why I move it to the top. And now the tensor of extract is I32. The OP type is I32. If I don't have this line, then at the first if condition, it tried to create a modal constant with the integer attribute with the integer type, which is illegal. Modal type with the integer attribute is fine, but integer type with the integer attribute is not allowed. That's why I needed to add this line there. Okay. Then, yeah, this is the materialize, and the second is modal. If I look at the modal dialect with the materialized constant method, the new code is something like this. Before that, I remember this line was not added. Now I added this because this time I supported like creating a one reason is like for example, oh shoot. Oh. So the reason why I added this second is because yeah, I can tell you the reason after case 3. So for example, in case 3, this else branch was not added previously, but now if we have a CMP operation with a dance attribute, it returns dance int element, the tag of Boolean.
Is it arith compare or mod arith?
Arith compare. It's a mod arith compare. Yeah, regardless of integer comparison or mod arith comparison, return type is always Boolean attribute or dance int elements attribute. So if it is a single one, then it returns bool. If it is a multiple result, then it will return something like
I see.
this.
Actually, this should call materialize using the arith materialize, not constant like mod arith materialize.
But because it's folded inside the model array dialect.
But actually, I think the materialize can be offloaded to no. Is it
Oh yeah. That's why I delegate the materialize using array constant. So this hook is called, and we create a array constant. Yeah, so array constant materialize will be called from this.
Really? I thought
no. Sorry. Maybe we should change it to this maybe.
No, is it?
Maybe we need to use this syntax maybe.
I think we should call the dialects one. Arith dialect materialize maybe.
You mean
Materialize constant. Yeah.
Could be. Yeah, maybe I need to fix this later. Yeah. Because I see this line before, so I just added this like without thinking that much. Yeah, but yeah, maybe you're true. I needed to call arith dialect materialize constant. Yeah, anyway, the reason why this was called is because it folded happened in the modal arith dialect. And there are 3 cases that I want to tell in this presentation. Case 1 is like, there are 3 typical cases that I use fold. One is like general binary folding or unary folding that has input of tensor and returns a same type of tensor. So for example, in this case, we got the type, we got the modulus, we got some callback, and because all constant folding always guarantee the right hand side is constant, so we check that whether right hand type is like integer attribute or dense mode arith elements attribute. If it is an integer attribute, and we also check that whether left-hand side is also constant. And if it is constant, then we calculate immediately. And if it's not, then another purpose of the canonicalization is to reduce the number of operations. So now we are going to remove add operation by returning left-hand side only if the right-hand side is 0. And we do the same thing for dense elements case. And the consideration we have to make for this is like, so it could be very expensive, like if we have dense elements and only the last element is non-zero, then that in this weird situation, this could be expensive. But hopefully user use splat for this, or user have a very random elements in the beginning so that it doesn't go to all the elements in the dense elements. That's my hope.
What? Okay. Where does it check the splat? Does it check splat?
Inside, if it is splat, then it uses a specialized iterator inside.
The all of?
Yes, I mean value. You mean this returns iterator,
Okay.
and it creates a special iterator when it is a splat.
I see.
So yeah, if I repeat it again, so constant folding is called because the right-hand side is constant. If the left-hand side is also constant, the calculation is performed immediately. However, if the left-hand side is not a constant, the next goal is to reduce the number of operations. So x plus 0 becomes x. And big-cast operation is also special case because it returns a different type other than mode array. Case 3 used to also return a different type. Yeah, anyway, in the case of bit-cast operation, the conversions occurs between the types, between, for example, 2 by mode arrays and 2 by I32, kind of. Therefore, this dense mode arith elements attribute is converted back and forth between dense int elements attribute. This requires logic in like to handle this inside this, because it must be a arith constant, which is not a mode arith constant. And the reason why I added this to the command is because here this, if it is creating a dense elements, dense mode arith elements to dense int elements attribute, it doesn't incur any copy because it's a purely big cast. But if we create a dense mode arith attributes from dense int elements attribute, it incurs copy because this one doesn't know about our type. Maybe we can add a patch for this small part for only for big cast part, but maybe yeah. Now I need to have a copy for big cast here.
Oh, is it copying the whole dense elements?
Yes, while lowering, because it requires array value ref for small vector or something like that, but I don't know. Yeah, maybe there's a way, but yeah, I don't know the way to do at this moment. So I just call this and to the command. Maybe if we have a better idea, then maybe the best way is like just big cast, not the copy. The reason why I do like this is, yeah, I expect it to return ZkIR dense elements attribute, but if you use the big cast, then it returns dense int attributes, which is not my expected type. But in this case, yeah, our big cast, I assume that if if you call bigcast, you're going to change it to dance int. That's my assumption, though. Yeah, technically, it's not a. It's kind of bigcast with a assumption, though. Yeah. Anyway, this type is changed. GKR dance to dance. This
So the ZkirDenseElements contains vector of AP int, right?
yes.
Is it possible if we, instead of storing vector of AP int, we store dense int attribute?
Actually, for both like dance int or for both our dance something, both of them stores in a just a array of array of character.
I meant, so yeah, I mean, in our case,
Yes.
can we store in a dense int attribute? Do you think it's possible or no? In ZkIR dense, so it's a wrapper of dense int elements attribute with a type?
I think that's also possible because the lockpick thing is like, so this, I mean, all this child class doesn't have a member, which means the memory layout, all of them are same, even with our ZK dance elements, all of them size are same, layout is same, memory layout is same. So yeah.
I'm just mentioning that because, so as you know, probably the copying attribute is very cheap, right?
Yes.
So you can construct ZkIR dense elements attribute easily without copy from from dense int elements attribute.
That's also true. Yeah, maybe, yeah, we can, I mean, improve our code better using that, maybe. Yeah, inside, we treat it as a dance int elements, but or we could become a child class of dance int elements. Could be, but with a different type. But but we need to be care, like if you call like any method inside the dance element, could potentially crash your program because that assumes that element of type of this attribute is integer. If you doesn't follow this rule, then always have a possibility of crash. So the safe way to do is like completely separate implementation from dance int is that's safe way, but yeah, because of that, yeah, I have this kind of inefficiency. Also, I have some code duplication. So yeah, maybe we need to think better way if there's have a better way. Yeah.
Yeah, I agree that inheriting maybe cause some unexpected crash here and there. So maybe just having a field of dense int elements attribute is
if you don't, it's not allowed to have a member.
Okay.
Because all of the reason why safe to casting around dance int or FP or between dance elements is because the size of struct is same. If you have a member, then you're going to lose some information between casting.
I see.
And the last case is like, so it accepts tensor of modal width and it returns Boolean or tensor of integer attribute. And yeah, it's also special case for folding. So in this case, if it's scalar, it returns Boolean attribute. If it's a tensor, then it creates a dense int elements attribute. That's why, yeah, we need to handle both of type inside this. Yeah, that's all of my presentation. And I think, yeah, I cover most of the concept in the PR, but yeah, probably there will be like the unexpected code that you find, and maybe this is because the code for like iterating and the code for parsing, like And this also I drew from MLIR. Maybe that one could be a code that you will be surprised. But I also left a comment in a definition of the class that you can find a real original source code from there. So maybe you can compare, but mostly I didn't make any modification for like when I copy, and I try my best to not to reduce the number of copy too.
I see.
Yeah.
Thank you.
Yeah. Oh yeah. Good. I stopped recording first.